Hi guys, welcome to another lesson of AP Statistics. Hopefully, before watching this video, you've already watched the video. Would you fall for that? Okay, why do you think the people in the video got stronger? Although there was really nothing, no chemical component in that drink that they were drinking. So, but why do you think that the people in the video still got stronger? So, they thought that they should be stronger, so maybe they tried harder. What do you guys think? Right? And so even though there's nothing on it, but because they believe there's something on it, it magically made them stronger. And that is what we call the placebo effect. Okay, similar to the video, Mrs. Gallas wants to use a beverage to test the effect that caffeine have on the heart rate. Here is the initial plan. So she wanted to measure the initial pulse rate, of course, and then after that she'll give each student. So if she has 30 students in there, she'll give all 30 students the caffeine. And then she'll use Coca-Cola or Coke in here. And then she will wait for a specific time, maybe after 20 minutes or after an hour. And then she will measure the final pulse rate. And remember now, she's giving this to all her students. And then finally, she will compare the final pulse rate that she took after they drink the caffeine and then the initial which she took before they drink the caffeine. What are some problems with this plan, and what other variables will be the sources of variability in pulse rates? Maybe you could think of more problems that um will happen in this situation, but I have listed three things in here. Of course, the first mistake that she did is that she's giving it to all kids, right? So usually what we would do is that we'll give half of the students caffeine, and then half of the students will get the caffeine free drink, right? So that way you have a group to compare the result to. And that's one of the mistake because she gave it to all her students. And so there's nothing to compare to. We call that there is no control group, right? A control group would be a group will not drink the Coke with caffeine or something, a caffeine free drink. Now, aside from the caffeine that is gonna make their heart rate go up, could it also be sugar? Because of course there's a lot of sugar. Could it be that it's not the caffeine that makes the pulse rate go increase? Could it be that it's the sugar intake that the kids did? Yep. So another one in here is that we need to control other variables. So we have control and then control other variables. And then lastly, we have the last one that I have. Maybe you could find another mistake. People know that they are getting caffeine, so it could be just the placebo effect. And because they know that they're drinking the Coke with caffeine on it, it could be that because they're thinking that there's caffeine on it, it will increase their heart rate. Could that be right? So to solve that problem, we do a blinding experiment. And blinding experiment is not to blind them, but blinding experiment is just as simple as she should have covered the cup or whatever, then or she could blindfold the kids, and then she would have two drinks, one with caffeine and one with no caffeine, and that so you could eliminate the placebo effect because this time, you know, kids might kids does not know what they're drinking. Okay. um Design an experiment to test the effect that caffeine has on heart rate, but this time we are now providing solution to each of the problem. So why don't we take the students? So let's say we have 100 students. Take all the students and randomly split them into groups. So we have 100, we have 50 for the first group and the other 50 for the second group. And then we give one group the regular Coke, the one with the caffeine, and then we give the other group the caffeine-free drink. And then from there, we will compare their change in heart rate. Now, let us design an experiment. So we call this one, let's put a name, completely randomized design. Okay. You know how in the observational studies we have on the survey, we had stratified, we have simple random, we have cluster, right? And in the world of experimental study, the first method that we have is called a completely randomized design. So this is technically the simplest design of an experimental study where you have 100 students. That's too much though for one classroom, Rabab. Whatever. So we have 100 students, and then of course we randomly assign them. We do a random assignment so that we could eliminate other factors. Let's say, you know how we had the sugar might increase the pulse rate. So in order for us to, you know, make sure that it's not just because of the sugar, it's because of the caffeine. We randomly assign the kids into different groups. And we have group one here. Let's put 50 students in there. And then group two, we'll put 50 students. So again, this is randomly selected. Okay, so you don't know which one will end in group one, and no, you don't know which one will be on group two. And then we will provide treatment one, which is the Coke, and then treatment two, well, I should call that regular Coke, and then the other one is the caffeine free, right? The one with no caffeine. And then what I would do is after that, I would have to compare the result. And so our last here is compare. Um, Instead of saying result, let's put compare heart rate or the pulse rate, technically. Same thing. Okay, is that making sense, you guys? Easy, right? So you have the whole group of students, you randomly assign each student to each group, and then you give them the treatment. And to make sure that the placebo effect will be somewhat controlled, we need to make sure that the students does not know which type of Coke they're drinking, right? So you're gonna do a single blind experiment. Single blind experiment means that the one that is receiving treatment, she does not know which treatment she is receiving. Okay, so for our big ideas section, we have the control group. We use the control group to provide a baseline data for comparison. And then blinding, I have already mentioned that. We have a single blind and a double blind. So a double blind would be in cases where the bias of that the experimenter, the one that is doing the experiment, might have a bias. So it's a good idea to do a blind experiment where two double blind experiment where the patient does not know what treatment she's receiving, and then the doctor or the one giving the treatment also does not know which medicine or which treatment the patient is receiving. But of course, there's another person, the third person behind all of this, that is doing the recording. It's just that the doctor or whoever is doing for example, if this is an interview, whoever is doing the interview, um, let's say about pain, right? So if the doctor, if the patient is drinking a pain medicine versus a placebo medicine where there's nothing on it, and then the doctor will ask them about how their pain is, if it's decreasing or not. It's good if the doctor does not specifically know what medicine the patient is receiving. So that's called double blind. Okay, we also have here a four key principles of experiments. If you open your book, you would see something like this, the four key principles of experiment. And there's so many examples in your book. But let's go through for this quickly. Oh, let's put what is this one? CRCR, right? The acronym. So C is comparison. You need two or more treatment. You need, of course, with Mrs. Galas, she didn't have a comparison, so we need to have a comparison, two or more treatments. In here, our caffeine versus no caffeine. We need to do a random assignment, of course, and then we need to control the other variables, and we did right by randomly assigning them. So number two and number three kind of similar, and then replication. Always this always comes out. Replication is that there is a difference between replication in biology and replication, or psychology also has a replication, and replication in AP statistics. The replication in biology means that you do an experiment now, right, with 50 people, and then you do another experiment with another 50 people. That's what replication in biology or psychology is. But replication is in AP statistic is that are you using enough subjects? Are you using enough patients to distinguish the difference between the two treatments? Okay, and I hope we're going to have more examples on that, but I hope you're not going to get confused between the two kinds of replication in biology and in AP statistics, those who are taking AP biology. Okay, let's try to check our understanding. Many utility companies have introduced programs to encourage energy conservation among their customers. An electric company considers placing a small digital display in household to show current electricity use and what the cost would be if this use continued for a month. So the first one is a small digital display, and then will the display reduce electricity use? And then there is another approach, a cheaper approach. Instead of putting a digital display, they're gonna give customer a chart and information about monitoring their electricity use from their outside meter. So one is to put a digital display, one is to make the chart, and then the company decides to conduct an experiment using 60 households to compare these two approaches. So we have a display approach, we have a chart approach. With a group of customers who receive information about energy consumption but no help in monitoring electricity use. Now for A, explain why it was important to have a control group that didn't get the display or the chart. So of course, they're only proposing two, what is that called? Um, Two ways or two displays. One is a digital and one is a chart. So if we want to compare which one is better, of course, we need to have a control group. We need to have households who do not have either the display or the chart. Okay. So allow letter A, it allows us to show how much electricity customers normally use, and it provides us the baseline data. So the control group again would provide us a baseline data. So instead of with two groups, we now have three groups. So we have the display, we have the chart, and we have an additional, which is households that are not receiving any of those. Describe how to randomly assign the treatments to the 60 households. And remember, we have three treatments now. How are you guys going to do it? So obviously, my favorite word, label all the households from 1 to 60 because we have 60 of them. And then we're going to use a random number generator to choose 20 distinct numbers between 1 and 60 because if we have 60 households with three displays or three treatments, I should say, we need 20 in each group, right? And then we will repeat that. Once we get 20, we will give that one to assign into the digital display, and then we'll repeat the process by 20 or more numbers, um, ignoring repeats, of course, and then we'll assign them to chart, and then the remaining 20 will get nothing. They will not get a display or a chart. There would be our control group. Now, what is the purpose of randomly assigning treatments in this context? Now, why do we have to randomly assign? Why don't we just do, okay, the first 20 households that are all together in one line or in one block, they get the chart. The next 20, they get, why can't we just do that? Right? Why can't we just, isn't it that easier to do that? Like, oh, the first 60 in the list, you'll get chart. The second 60, you'll get a display, right? Why do we have to do a randomly assignment? So, doing the randomly assignment, it creates roughly equivalent groups by balancing other variables. You know how earlier, what if the sugar would affect them, and it's not because of the caffeine, it's because of the sugar, and that to eliminate that thinking, we need to randomly assign these students, right? And same thing in here, and let us create the design. So we have 60 households, 60 households, and first thing we need to random assignment. So we use the random generator, right? And then we'll, what is that? And then we will use, for some reason, something is happening here. Okay, hold on. And then we will use 3 treatments. So treatment 1, can I just put T2, T3? So this one will receive a chart. This one, it doesn't matter which one, yeah. This one will receive a display. And then this one is our control group, which will receive nothing. And then, I'm forgetting. I am forgetting. I am forgetting something. Sorry about that. The first thing we do is to group 1, group 2, and group 3. So that's 20, 20, 20. And then you do this. So treatment 1 would be the chart or the display. It doesn't matter. Treatment 2 would be the display. And then the treatment 3 would be the control group, which will not receive anything. And then, of course, after that, we will compare the result. But what's the result? We will compare electricity usage, right? We put that in context. We will compare electricity usage. And then there you have it. This is what you call, please make sure you know what that is called. They completely randomized design. Okay? So I also have in here the completely randomized design. So, you know how in observational studies, in the world of observational studies, we have a simple random sample. So this one is an kind of an equivalent to it on an experimental world where we have a group of students, a one whole group, and then we assign them directly to different groups. So tomorrow on the next video, we will be dealing more on other methods of doing experimental design. Thank you guys. I will see you on the next video.